I'd like to introduce Seth Grae, Chief Executive Officer of Lightbridge. Lightbridge is a nuclear fuel technology company developing advanced metallurgic fuel design to enhance the safety, economics, and power output of existing and new light water reactors. So they have around 34.5 million shares outstanding, trading around $10 around a 360 million market cap. Maybe we could just begin with a brief overview and just take it from there.
Yeah, sure. So Lightbridge is different from a lot of other advanced nuclear companies you hear about. What many companies are doing is developing new advanced reactor ideas around old nuclear fuel concepts. Lightbridge is developing completely new nuclear fuel, and this fuel can work in the existing reactors as well as many of the new ones. We started out by talking with major utilities that own and operate the large reactors that provide almost all of the nuclear power in the world from these types of reactors, and heard that they would like to increase their capacity factors. They would like to increase the power output significantly from the existing reactors while enhancing safety further. And they could not do that with the kind of fuel used in reactors today. So we're really the only company that went about to really reimagine and redesign the fuel for reactors. And we've been making tremendous progress. We have fuel samples now in testing at Idaho National Laboratory in the Advanced Test Reactor there. We're advised by utilities, in contact with utilities that would like to see these advantages. We've been growing as a company with many new engineers at the company now. And we think that we're really rendezvousing at the right time, just when the world needs a lot more reliable power and a lower cost per unit of electricity generated with the ability to do that. So that's really what we're doing as a company.
That's a great overview. Maybe just diving in, how does Lightbridge Fuel's power uprate capability compare to what's currently available on the market? And then, does that apply equally to large operating reactors and SMRs, or just one?
Right. Well, we believe it applies to both. Our work focuses more on the large reactors, but there are two Department of Energy funded grants through their Nuclear Energy University program, one at MIT and one at Texas A&M University, looking at the Lightbridge fuel for NuScale's SMR. And we've also done some preliminary work looking at our fuel for other SMRs. And from what we've seen so far, we believe it would apply to the pressurized water reactor SMRs like NuScale's or Rolls-Royce's or Holtec's, or the boiling water type SMRs like GE Vernova, Hitachi's. But our focus is the large pressurized water reactors, which comprise the overwhelming majority of all nuclear power in the world, and virtually all of the reactors under construction or on order in the world, and I think will be for a long time. And in terms of how much of a power uprate, some of the testing ongoing now and to come will hone this a bit further. But we think for the existing reactors, for many of them, we could do up to a 10% power increase while lengthening the fuel cycle simultaneously from 18 to 24 months. So the reactors are shut down less often and producing power more often. That's without changing the steam generator in the reactor. Now, a lot of reactors are changing steam generators, particularly as their licenses are getting extended. They're getting 20-year license extensions. It looks like a lot of reactors will run for 80 to 100 years, and I think that's what the new ones will do. And when you change out a steam generator, I think we'll be able to get more than a 30% increase from switching to this fuel with a steam generator that could handle that much capacity. So, possibly around a third more power by switching to this fuel. And what we're seeing in the executive orders from last May from the president and the recent Uprise initiative from the US Department of Energy is this big focus on power increases to the existing reactors. And I think there won't be anything that come close to what Lightbridge's fuel technology could do to achieve those goals. We're also seeing a big focus on reopening closed reactors, on finishing partly built reactors, and I think Lightbridge Fuel will help justify the economics to do those things and make those projects more powerful. But in particular, as the US has a shared goal with many other countries around the world to triple nuclear power in the world by 2050. And as part of that, the US having a goal to quadruple nuclear power domestically by 2050, that the lower hanging fruit starts with reopening closed reactors, finishing unbuilt reactors, partly built reactors. But for all of them, including virtually all of the currently operating reactors, do significant power uprates. And there's a real focus on that here in the U.S. I think that's going to spread around the world, and I think Lightbridge will be at a center of that.
It sounds like there's a lot of large opportunities in front of Lightbridge. I guess maybe you could give us some context on the competitive landscape and how you see that evolving over time.
Well, we've always said that our competition is anything that can provide power. And I use the word power and not energy deliberately, in that power is available at the full amount all the time. Energy can vary in the amount of how much is available at any given time, like from wind or solar, or not be available at all at times. So, for example, an Uber that arrives at a random time or might not arrive at all is less valuable to you than an Uber that will arrive at a certain time. And it's like that with power. And reshoring of industry, building out data centers, especially for AI that need massive amounts of power, can only happen if the power will be available or no one will make that investment. We used to see things like competition for Amazon's supposedly called HQ2, where states and counties would compete by giving tax breaks and other incentives. Now it starts with, do you have the power? If you don't have the power, the company's not coming if it can't be guaranteed for a long time. If you do have the power, then you can compete for incentives. But and we're seeing a lot of companies, including with data centers, going offshore where they're being guaranteed power. And I'm in California today for a series of meetings, and I've been in nearby states in Arizona, Nevada, that actually provide a lot of California's power. Not because, in a sense, that was the business plan of their utilities, but because they have excess capacity. But we're also seeing that a lot of data centers are going to be deployed in these nearby states, including Arizona and Nevada. And I think that excess capacity will be reduced and ultimately disappear. I don't see California making plans for how it's going to make up for that. I think that's going to be a big problem here in California eventually. But I also think one reason why the data centers are going to those states is they're being guaranteed the power, particularly with large nuclear reactors in Arizona that are now powering the Los Angeles area to a good extent. And it really is AI more than anything that is just adding these tremendous power needs, fairly rapidly, and people I talk to at utilities in the U.S. and around the world are really under pressure to figure out how they will increase the supply of power, and they're under pressure not to increase the price of power. And those two things can go together, particularly with increases of supply at a lower cost point, and where you have, particularly hyperscalers and data center companies willing to pay a premium for power they know they'll get for a long time. Like Microsoft is paying about a 40% premium over wholesale power prices to lock in 20 years of supply from reopening the 3 Mile Island Unit 1 reactor in Pennsylvania to power data centers in the northeastern US and what's called the PJM area. And well, that 40% premium that they're paying to Constellation that operates that site uh, can be used to help provide more power, this kind of a virtuous cycle. That Constellation can use that added revenue, that higher price point. And I think that states, that are adding more power will end up doing better. It's sort of the lifeblood of all modern industry. And Lightbridge, again, I think will be at a big center of this because you just can't get to that level of reliable power at a massive amount of it without a significantly increasing percentage of nuclear within the diversified energy mix. We'll have hydro that can vary in power, wind and solar, and even natural gas and coal have much lower capacity factors than nuclear. A coal plant can shut down, and we've seen it a lot with ice on the tracks, et cetera, not delivering the daily amount of coal. And of course, there are the emissions issues, and natural gas plants have shut down during the polar vortexes and other freezes and issues that stop the gas from flowing through the pipelines. And as soon as the gas stops flowing, instantly the power plant shuts down. Nuclear reactors can have years of fuel on site and operate through just about anything. And so, it really is the nuclear reactors that are saving things in that. I'll give you one quick other example. So, France, it has the highest percentage of its electricity from nuclear in the world. And had France followed Germany's model and shut down their nuclear and instead relied on Russian natural gas, I think Europe could not have gotten through the winters and could not have stood up to Russia without buckling in supporting Ukraine. I don't think you'd have seen Norway and Sweden join NATO had Europe not had as much nuclear. And you're seeing in the current conflict that is apparently a little calmed down more today, but one attack from Iran on one site in Qatar shut off 20% of global liquefied natural gas exports for a long time. Again, that can't happen in nuclear. You could have years of fuel at every single site where reactors are, and fuel lasts years in reactors that's already placed into the core, but you could also store a lot more at the plant, which you can't do with other fuels. So we're very bullish on nuclear, and in particular on Lightbridge's place as nuclear develops.
Very comprehensive response there. Maybe just digging in further, large reactors still dominate, the nuclear fleet today. Maybe you could talk to how Lightbridge thinks about the installed base and commercial opportunity, and then, what's the path to marketing that?
Well, the installed base is 94 operating large reactors in the U.S. and more to come, particularly as 3 reactors are in the process of reopening before even building new ones. And that's out of over 400 operating large reactors in the world that we believe could use Lightbridge as fuel. And the market, if that does triple worldwide in the next 24 years, but between now and 2050, and quadruple within the U.S., the market opportunity is very significant. Now, we're taking this one step at a time. We've produced fuel samples. We have samples of this fuel material in the Advanced Test Reactor at Idaho National Laboratory. We expect to have programs demonstrating segments of our fuel rods in the coming next few years in reactors powering cities in the US, and then full fuel rods and what's called lead test assemblies, which really the final commercial product being demonstrated in commercial reactors. But unlike a lot of companies that are developing reactors that are really just focusing, as we see it, on the NRC, some of those companies, on getting the Nuclear Regulatory Commission licensing, we're of course doing that. But we're really focusing on listening to the voice of the customer too, the utilities. And some of the utilities have different requirements than the NRC does, in addition to what the NRC requires, or something that goes beyond that. The industry has its own group, the Institute of Nuclear Power Operations, known as INPO, that utilities belong to, and help drive, very strong safety and operating results. And so it's very important to us to constantly be listening to the voice of the customer, getting their input, and making sure we're developing something that we think they're really going to use commercially.
On the topic of safety and non-proliferation considerations, I guess, how does that factor into your design? And then I guess, why does that matter as the world moves towards a significant expansion of global nuclear?
Yeah, I think it's a great question. And first of all, we have engineered in, we've designed in enhanced safety and non-proliferation by design. So it's like with cars, in addition to having speed limits, having anti-lock brakes, having crumple zones, having systems in the car itself that enhance safety. And as nuclear, say, triples around the world, and we add, over 1,000 new large reactors or thousands of small and micro reactors in that mix to triple nuclear around the world, it's very important that we have enhanced safety and non-proliferation by design in those thousands of reactors around the world, and not only rely on an inspection regime, on a safeguards regime, which is a little bit like relying on speed limits. And I think that also there are economic benefits to that. Right now, utilities pay a lot of money for nuclear safety grade equipment that could potentially be commercial grade with Lightbridge fuel because of the serious safety benefits of the fuel that could save the utilities, additional money every year and increase their profitability. And we think that one of the things that keeps nuclear acceptable in the US and around the world is its safety and non-proliferation record. So we are looking to enhance that even more.
Maybe just shifting gears, if you could give us an update on the testing program at Idaho National Laboratory's Advanced Test Reactor. Maybe if you could talk about what you're testing for, and then what would a successful outcome look like?
Right now, we're testing material samples of the metallic alloy our fuel is made of. This is with actually a higher enrichment of uranium than the commercial fuel will have, because the U.S. Department of Energy gave us access to that. And that allows the testing to be done faster than it normally would be. One of several things that have sped things up, and I think will continue to speed some things up in what we're doing in the way the national labs and the Department of Energy are working. And these are testing what's called the thermophysical properties of the fuel. We'll see the microstructure, different things as we go through the testing. This reactor will hit an outage in about late April, later this month, into early May, when some of these samples will be removed and cooled. And then we expect by the fall and later this year to have different results from how this is looking, which we expect to go very well. In parallel, we're doing other testing outside the reactor. We're doing what's called thermal hydraulic testing, and we'll have much more on high temperature, high heat tests, see how this fuel does, within any conditions it could face in a reactor. And so, the bottom line is it's both everything the Nuclear Regulatory Commission will need to see is what this program overall will provide for us to be able to have a license from the NRC to commercially produce it and provide it to utilities, and everything that the utilities will need to have a license from the Nuclear Regulatory Commission to use this fuel in their reactors. And part of that process will be testing rods and bundles of rods called assemblies in some of their reactors as well. So how to qualify a nuclear fuel is actually a well-known process that the current fuels went through, that the Nuclear Regulatory Commission, that utilities are familiar with. We're just the first ones using that on what's really, truly a new fuel to bring what the customers are looking for as benefits.
And then maybe just looking at the global landscape, 200 reactors, new reactors being developed today, most of those being built with existing fuel technology. How does Lightbridge position itself as the fuel solution for the next gen of reactors?
Yeah, so these are, around the world about 200 different kinds of reactors being developed. These are not, for the most part, actually being built yet. Some of them are just PowerPoints with designs on them. Some actually are under construction, but very few around the world. And these are different ideas, from molten salt to pebble bed, different types of fuels and reactors, but really old fuel designs that were demonstrated in the 50s, 60s, 70s, 80s, with innovative reactors being developed around them. And within them are the SMRs, that the ones that are water cooled, like the pressurized water reactors, like I said before, like NuScale, or the boiling water reactors, like the ones from GE, Vernova, Hitachi, that we expect could use Lightbridge fuel. And we think there will be use cases in many of these types of SMRs built. There are already some of them under construction and on order, and we expect to see more. And we expect that to be a very good market for Lightbridge fuel. But again, I think the large portion of our market will be not just starting with the existing large reactors, but that most nuclear power in the world will be produced by large reactors for a long time. And that will be our biggest market, not just because so many of them are on order or under construction, but because they make so much more power than the smaller reactors from each unit.
Maybe just shifting to adoption dynamics. What's been the feedback from utilities so far, and I guess what typically needs to happen internally for a utility to consider switching to a new fuel type?
Look, these are very deep engineering and regulatory discussions among experts, and looking again at the NRC and the utility zone requirements, as well as down to the level of people at local plants, getting familiar with what they might face ultimately. And it starts with, again, that the utilities are just looking for how can they provide more power, energy that's reliable at the full amount, reliably, and do so at a lower cost for generating power. And anything that can do that can have a place in this market. I think that of all of those ideas, power produced by the Lightbridge fuels will have the most power produced and at the lowest price. It's why we're so confident in this area. And it's partly because when we started this effort, based on conversations with utilities, really nobody else decided to go out and develop a nuclear fuel to accomplish these goals. And again, while I think there will be use cases and big success stories among small reactors, um, in a world that needs much more power, the big reactors providing a lot of power are just going to be, I think, a very important use case. And while there will be co-location of some reactors at data centers and in other places, for the most part, it's getting very hard to site a data center or other facilities. Try siting a data center with a nuclear reactor and convincing a local community to have a data center and a nuclear reactor built there. Reactors tend to get built most successfully on existing sites that already have operating reactors or adjacent to those sites where they have cooling water, they have an electrical switchyard, the connection to the electric grid, they have a trained workforce, but most importantly, they have a local community that has the employment, has the tax base, and trusts their neighbors that are keeping it safe and are working at the plant, and the plant is part of the community. So I really think that's going to be the case, that most new nuclear power, in addition to power increases from current plants, will be from new reactors added to existing sites and adjacent to those sites.
I'd like to just turn briefly to the audience, and if there's any questions, otherwise we'll keep going. All right, maybe just last one to kind of summarize everything and tie it all together. 5-year plan, how do you envision things, dynamics evolving?
Yeah, it's been a very good last couple of years for Lightbridge. I think that's going to continue over these next 5 years. I think you will see, a model that we'll put out in probably the next couple months that will help you and others build a financial model with some dates and costs, of what we're doing as we roll this out over that period. We'll go through this testing in the Advanced Test Reactor and other testing. Very importantly, we will decide on a location where we will build our pilot plant to produce our fuel for use in commercial reactors. As we're outgrowing the current facilities we're using at Idaho National Lab, but Idaho National Lab will stay a very important partner to us for work there that we're doing with experts there and facilities there. And this will be, for the first time, an expandable fuel facility where it will be on a site with security, with licensing, with everything needed to grow and develop a commercial facility on the same site as there is more demand commercially for our fuel, and to give the customers the comfort that as they demonstrated this in their reactors, it will be able to grow and provide more fuel going forward. And there'll be some partnering, some things we'll do with other companies. It's well known we're looking into some cooperation with Oklo, and I think that's a partnership that will grow that looks very good, I think, for both companies.
Well, thank you, Seth. That was a great overview and discussion. We're excited about Lightbridge, and we look forward to having you guys back next year, so thank you.
Well, thank you, Michael. Really appreciate it.
Lieutenant Colonel Tony Bancroft, United States Marine Corps Reserve, is a portfolio manager and a research analyst. Michael Burgio is a research analyst at Gabelli. The above webcast is an excerpt from Gabelli Fund's 12th Annual Waste and Environmental Services Symposium, which occurred on April 9th, 2026. GAMCO is providing these links as a matter of general information. We do not intend for these links to be a complete description of any security or company, nor is it a research report with respect to any of the companies mentioned herein. As of March 31st, 2026, affiliates of GAMCO Investors, Inc. beneficially owned less than 1% of all companies mentioned. The analyst's views are subject to change at any time based on market and other conditions. The information in this posting represents the opinions of the analyst and is not intended to be a forecast of future events, a guarantee of future results, or investment advice. Views expressed are those of the analyst and may differ from those of other GAMCO officers, analysts, other employees, or of the firm as a whole. Because the investment personnel at GAMCO and our affiliates make individual investment decisions with respect to the client accounts that they manage, these accounts may have transactions inconsistent with the information contained in this posting. Certain GAMCO personnel may know the substance of the posting prior to its posting. This webcast is not an offer to sell any security, nor is it a solicitation of an offer to buy any security. Stocks are subject to market, economic, and business risks that cause their prices to fluctuate. When you sell shares, they may be worth less than what you paid for them. For more information, a prospectus or summary prospectus, visit our website at Gabelli.com or call 800-GABELLI or 800-422-3554, info@Gabelli.com.